often happen to these functions to make them have x-intercepts. If you slide them around a little bit, move them up and down, perhaps you get an x-intercept. But in general, they don't have them. Not only that, they're always positive. These functions are always positive. Agreed? The picture only lives above the x-axis, so every function value that comes out is positive. All right, now I want to find the derivative of this thing. Derivative of b to the x. I'm just going to tell you. d dx of b to the x is itself back again. It is b to the x back again. No matter what the base is, it doesn't matter. But it is not like e to the x necessarily. Only e to the x has a special quality that is itself completely. This has a compensatory factor of ln of b. Right? So there is this multiplicative constant here. That guarantees you have the correct rate of change. So very simply, if you had the function f of x equals 2 to the x, then what is its derivative? What is f prime if your function is simply 2 to the x?
ln 2 times 2 to the x.
That's right. The constant natural log of 2 times the original function 2 to the x. So it's extremely similar to e to the x. All the exponentials are similar, that they come back, right? Derivative of 2 to the x has 2 to the x back in it, unlike other functions. Derivative of sine doesn't have sine in it, right? Derivative of tan doesn't have what? Doesn't have tan in it. So ln 2 to the x. So now what happens if you use base e? So if f of x is e to the x, if we follow a little formula, so you're going to get the natural log of e times e to the x. What's the natural log of e? 1. And so that's why e to the x is its own derivative, based on this formula. So 1 times e to the x is e to the x. But all the other bases have some sort of compensatory factor. The natural log of the base is what causes it to be the actual rate of change. Everybody okay so far? Just want to apply this to larger class of exponential functions besides base e. No big deal. Now that doesn't matter whether the base is between 0 and 1 or greater than 1. It's all going to be the same. Natural log of base times original exponential function. All right. Now let's talk about natural log. Or log in general. Y equals b to the x is exponential function. The inverse function of y equals b to the x is what? Y equals log base b of x. These two functions are inverses of each other. This is the important property between them, which explains everything basically about the log function. So what does it mean to be inverses? It means to switch up x and y, correct? So for example, we'll take 2 to the x. We have 2 to the x here. It's about like that, like the picture I just drew a second ago. Okay? There's 2 to the x. If I want to draw the graph of log base 2, it's inverse. That's what I want to do. So over here, log base 2 of x. We want that function. Okay? So at what point am I guaranteed, just looking at the picture of 2 to the x, what point am I guaranteed is on log 2x?
0, 1.
1, 0.
1, 0. Since 0, 1 is on this function, then the inverse function must have 1, 0. So whereas this one has a y-intercept, but no x-intercept, this one has an x-intercept, and it's not going to have a y-intercept. So 1, 0. Must be on the graph of this one. Since this one has a horizontal asymptote, this one must have a vertical asymptote. Because all inverse functions do is switch the role of x and y. It's the most basic and important way to view these things. It just switches the role of x and y. So we have a vertical asymptote here. Asymptote at x equals 0. So y equals 0 for the horizontal over there, right? All right. How do you construct, given very little information, how do you construct an inverse graph from the graph of the original?
X and Y.
You flip x and y. So you're going to reflect the 2 to the x function about the line y equals x. So if you reflect this thing about y equals x, then you get a picture that looks somewhat like this. Like that. Okay? That's how you obtain the graph of any inverse function. It doesn't matter. Right? So now, this is no different. This log base 2, coming from the 2 to the x, it wouldn't have mattered as long as b was greater than 1. So then you're going to have this case, and this is the basic structure of the graph. So now the limit as what? As x approaches infinity is heading towards what? What's the function heading towards? As x gets further and further to the right. Infinity. Slowly. Extremely slowly. Is that too many leads? Extremely slowly. Extremely slow. Right? But it is heading towards infinity, as opposed to this one, which is going very quickly, right? Exponential is known for its very fast rate of change. The logarithm is known for its very slow rate of change. But it is an increasing function. What happens as x approaches what? What else can x approach?
Negative infinity.
It cannot, because it doesn't exist over here. There's no graph over here.
And approach 0.
0 from
The right.
yeah.
Oh.
It can't approach from the left. There's nothing over there. So as x approaches 0 from the right, where does this thing go?
Negative infinity.
That's right. So this is now the basic graph information about log. Now, an important thing to note is, whereas the exponential function, what is its domain? Just looking at the picture, what's the domain of exponential? Domain of b to the, it doesn't have to be, it could be anything, b to what is?
Negative infinity.
All reals. Negative infinity, positive infinity, right? Put any number you want into an exponential. But it only costs out what kind of numbers? We said a second ago. What kind of numbers does it put out? Only positives. Okay? How do you obtain the domain and range of an inverse function from the original? Switch it. Because what's an inverse? All you do is switch up the x and y. So even without the picture, we could claim that the domain of logarithm is going to be what? 0 to infinity, and it is from the picture. And the range is going to be what? All reals. Has to be. Okay? Is this too much for a review of logarithm for you guys? Too much pre-calc?
Pre-calc.
No? Or you guys remember the inverse stuff at all?